All right, welcome to Blue Pen Land here. Okay, so this is a pan pipe, right? Notice that one end's open, one end is fixed. Okay, so let's draw some of these one end open, one end fixed pipes. Ooh, so straight. Here we go. The rest of the drawing is not going to be so pretty, but maybe I can draw straight lines. I'm really good at it. All right, there we go. There's another pipe, and here's another pipe. All right. Okay, and then the first mode, the fundamental, I'm going to fail at this, but it's got an antinode here and node there. Let's see if I can draw it. Imagine that that's actually sinusoidal and not just all wibbly wobbly. This guy looks like the little fish guy, right? So this is like, well, we've got a node there, antinode, right? So it's like, now if you totally lack artistic ability, you can just write A's and N's, right? Antinode, node, right? Anti, node, anti. Anan. Now let's see, this guy is Doot, a fifth of the way in, and then there's this guy here, right? I've drawn these for years. There we go. All right, so this is Anan. Anan. All right. All right, so that's what the pictures are, right? So we just drew them, right? And let's see, we know the velocity is 321 meters per second, and we're going to use v as f lambda to figure this out, right? And then we know that these lengths are 0.622 meters, right? Even though they don't look the same length, they are. Okay, all right. Okay, so let's see. So calculate the wavelength. Okay, so the wavelength is not hard. Basically, the general form for this is the length of the pipe is some number of quarter wavelengths, right? You can always count quarter wavelengths, and with one end fixed, one end open, you're always going to have sort of like this spare quarter wavelength hanging out here at the end of the pipe. Here, in this case, we just got one quarter wavelength, right? So we go little number sentence 0.622 is just one quarter wavelength. Here we've got 1, 2, 3/4 wavelengths, right? So our number sentence is 0.622 is 3/4 wavelengths, and here we've got, let's count them, 1, 2, 3, 4, 5/4 wavelengths. So our number sentence is 0.622 is 5/4 wavelengths, right? So now we can figure out the wavelength. Let's do this. This is math. All right. So 4 times 0.622 is 2.488. Or 2.49 if you're going to do sig figs. There we go. All right, that's my lambda, right? Okay, and then here I'm going to go this times 4 divided by 3, so 0.622 divided by 3, and I get 0.829333333. So lambda is there we go. Am I getting them right? Let's see. Yes, there we go. Got that guy right. I got that guy right. Okay, so then this guy I'm going to go this times 4 divided by 5, so 0.622 times 4 divided by 5, and that is 0.4976. All right. Okay. So now we want to find the frequency. The frequency we're going to use v as f lambda, right? So in this case, I'm going to go 321 is equal to 2.488. That's the lambda times the frequency, right? So v is lambda frequency. I guess I wrote them backwards, right? So the formula I'm using is v is f lambda here. This is our v. This is my lambda. That's my frequency, right? So 321 divided by 2.488 is 129.019292, et cetera, et cetera. Okay, So the frequency here, this guy is 129 hertz. Now at this point, if you recall that this one is 3 times and that's 5 times the fundamental, you can just sort of, bust that out, right? Let's suppose you forget, we can just use V as F lambda, right? Same thing we did here, right? So 321 is equal to some frequency times 0.8293. So 321 divided by 0.829. And then I'm just going to use a little trick here to type in the repeating decimal there. Oh, look at that. I get 387 is what I get. Yeah, there we go. 387.0587 hertz, so roughly 0.1 hertz. So there's my frequency. Right, and then here, this guy, I'm going to do the same thing, right? 321 equals some frequency times 0.4976. So notice I'm not using the rounded version of this. If you rounded to 3 sig figs and then you use the rounded version, you'll be slightly off. So 321 divided by 0.4976 is 645. Ta-da. Okay, now notice that this 129, if I go 129, right, times 3, I'll get 387, right? So this is just 3 times the fundamental frequency, right? This is the fundamental frequency. And then this guy, if I go 129 times 5, I get 645. So this is 5 F naught. The next one would be 7, and the next one 9, and so and so, right? So this thing has the pattern of 1 F naught, 3 F naught, 5 F naught, 7 F naught, 9 F naught, right? It's not prime numbers, it's odd numbers, okay? Yeah, all right.